so many features. So yeah, I thought this might come about. So I had a few different, I had an answer thought about. So I think it was like 4 dimensions of developments of kind of aspects of WASM that we're trying to improve. And so, one dimension is improving support kind of for the existing languages that already compiled to WASM. And so on this kind of axis, you've got threads, which are, just about or already shipping in browsers. SIMD, also approaching shipping. Exception handling, or first class support for exception handling. You were able to compile it before, but it wasn't ideal. So actual native support for exception handling. A little earlier down the pipes, or even earlier down the pipe, 64-bit memory, so you can have greater than 4 gigabytes, of memory available to single WASM instance. Multi-value, being able to optimize, be able to return things, multiple things in registers, as opposed to having to pipe all the multiple return values through memory. And bulk memory operations, so you can get really fast copies and other sorts of nice things available for threads. So that's one dimension, is improving existing languages. Another dimension is adding better support for new categories of languages that are not already compiling to WASM for various reasons. So, the big one there is host GC integration, especially if you're targeting the browser. You don't want to ship your whole own GC. Also, if you ship your whole own GC, that GC won't talk very well to the browser's built-in GC. So it's much better to try to use the browser's built-in GC. So how to do that from WASM is a tricky question. So, but lots of active work in the CG at the moment on this particular proposal, and really cluster of proposals. Included in that cluster, also function references, typed references to functions that you can call without a signature check, and tail calls for those categories of languages that, like tail calls, you really want this feature, be able to pop the stack frame at the same time as making the call. So that's the second dimension, enabling new languages. Third dimension, better host integration. So in this one, you have being able to convert between WASM i64s and BigInts on JavaScript. ES module integration, so you can use a WASM module as an ES module, so you can just import it from JavaScript and import JavaScript from WASM using the import statement or import definitions. And interface type, which is something I'm personally working on, which is how do I pass high-level values that aren't just integers in and out of WASM and JavaScript. So that's third dimension. Fourth and last dimension is, my mind, the emerging pure WASM ecosystem, which is the ecosystem that doesn't assume you have JavaScript and the web on the other side of WASM module boundary that says, I'm just WASM, I don't know what I'm running in. What can I do just with WASM? And so in this one, you have module linking. How do I have multiple modules, perhaps compiled different libraries from different languages? How do I link them together? Two, again, interface types, which is, I don't know what the other side is, but I want to give it a string. How do I do that? And then the last one is WASI, which Anthony mentioned earlier, which is how do I actually access, talk about files and network and other sorts of things when I don't really know what my host is. So these are broadly the dimensions I see WASM improving in.